hit record, and away we go. Okay, so again, feel free to let me know in chat if there are any issues with sound or mic quality. That will hopefully get better in the next couple of days when I get some new gear. So let's jump into it. So today we're going to be looking at 3D printing. So at the tech school, obviously, we have lots of 3D printers. Students love using them. We had a range of Up Mini printers, and I'll just quickly show you what they look like. I'm going to bring this across into my screen here. All right, so these are a lot of the printers that we had at the tech school. These are all the printers that we had at the tech school. You'll find that these are also the printers that you'll be using at schools a lot as well. So these are the great little portable Mini 2s. They're really small, they're really light. They've got a handle, you can pick them up and you can carry them around. So we had a lot of those. So I might talk briefly about those because a lot of schools will be using these as well. What we do have now, though, I'll just get rid of that, is we have a bunch of these machines called Gensers, 3D Gensers. There we go. So if you want to chat with... Here we go. If you want to chat with Matt about this as well, actually, when you're in the tech school, he is probably the guy to speak to about our Gens printers. I know Graham and Matt were kind of key in getting all of these into the country and into our tech school as well, which is great. So what I'll do is I'll quickly scroll up here. So we have quite a few of these Gensers. I haven't been there since we set up the new ones, but we've got these little ones here, the Gens 1 and the Gens Double, and I'll talk about how we use those as well. I'm just looking at the stream up here. I'm just making sure I'm still live. It looks like YouTube might be buffering a tad. All right, that's okay. I might just close my viewing window down. There we go. So that way it should be a bit easier. My bandwidth is okay, so it could be on YouTube's end, but I'm sorry about that. But we'll keep on going. So yeah, so we'll be looking at how these printers here, these Gens printers kind of work. I'm just going to move this screen as well. Up here. There we go. Okay, so they're the printers that we have at the tech school, like I said. So we've got a double, which is this kind of two-head one here for printing. We also have another printer, which is what is called a resin printer. I'm not going to talk too much about that today. I might actually do that in another session later in the week because it's a little bit different to how these ones work and how they print. But these are the ones we're looking at. All right, so what I'm going to do is I'll move that out of the way and I'll jump in here. Black. Rafi just onto level 21 on reading eggs, so we may be having these general pauses every now and then to congratulate dear Rafferty on his reading eggs achievements. All right, so what I'm going to look at for the 3D printing side of things is obviously before you can print something, you need a model, right? You need a 3D model to actually print. Now, there's lots of software out there that can model in 3D. We've used Blender quite a lot, 3D Studio Max, all those kind of big programs. But obviously, at this point in time, your students, probably won't have access to that software. So what we're going to do is I'm going to look at software that they do have access to, and that's called TinkerCad. Now, you may have used this before as well. So I'm going to actually have a look at using TinkerCad for our software and how that can quickly create a 3D model, which you can print. Now, obviously, again, if you don't have access to school, it's going to be tricky to print these models out. But when the tech school is up and running again, you can come in. Hopefully, you can encourage your students to do some 3D printing over the break. Actually, no, it's not a break, is it? over the home learning. Do some 3D printing, and then they can bring those models into the tech school when we're done, and they can kind of print those out as well. So I'm just checking and making sure my stream's okay. It's still live, so I'm sure I'm okay, but it looks like it may just be buffering on your end. So hopefully YouTube's okay down there. All right, so what we're going to do is I'm going to talk about TinkerCad and how it works. I'm going to talk about creating a 3D model, okay, and how to make that in TinkerCad, how easy it is to do that. And then I'm going to talk about getting that 3D model and taking it from TinkerCad into our 3D printing software and how that works. Because once you've got your model created, there's then a second stage, and that's the 3D printing stage, where you have a lot of settings to choose how that's going to work, how that's going to print. Things like slicing and beds and supports and those kind of things. So there's a whole other side of 3D printing that you kind of need to get your head around as well. And it's also a way of, if you know how a 3D printer kind of works, then you can kind of design your 3D model around the limitations of a 3D printer, okay? Because even though 3D printers are great, they're not foolproof. You can't just put a model in there and then, come back in a few hours and have a completely 3D printed model. So we'll see how we go there as well. Okay, so let's jump into it. So TinkerCad, it's free software by Autodesk. So Autodesk, of course, make big boy 3D software as well. So this is kind of like an entry level into that, which is why it's free. I think it gives students a chance to kind of play with with basic 3D modeling before they jump into some bigger software as well. So it's free. It just requires you to log in and create an Autodesk account, so your students can create a student account if they want to. You can also, as a teacher, create a educator account. And with that one, you can set up a classroom, you can invite your students into that room, you can share models, you can collaborate on 3D projects, those kind of things as well. So when you start TinkerCad, you'll have those options to come in as a student, as an educator to create a class, or just as a general user. So I've logged in pretty much as a general user because I'm guessing that's what you'll see as well. All right, I'm just going to make sure my stream is okay. I'm always worried about my stream. Let's just make sure it's okay. All right, again, let me know in chat if you're having issues with the stream, and I'll see if I can make some changes on my end. All right, so what we're going to do is we're going to look at how this works. So once you start TinkerCad, okay, you're greeted with some of your previous models that you've made before. All right, they're going to be sitting down here, and then you can pretty much create a new design. Okay, we'll talk about circuits and code blocks a little bit later, but I'm going to create a new design. All right, now I'm just going to double check. I just want to have a quick look at YouTube up here, and I'm just going to make sure while that's loading down there, I'm just going to make sure my stream's going okay. All right, so you can hear my fans going crazy, so I'm looking forward to getting that mixer very, very soon, so this won't happen. Okay, let's have a look. Cool, we're streaming fine. Excellent. All right, so it's working fine up on YouTube up there, so that's okay. Let me just close that down. Wonderful. All right, so I'm going to jump back in here. So now that you are in TinkerCad, okay, you can see the layout. You okay, bud? Yeah, cool. You can see the layout of what we have here. So we're working in 3D space, okay? So you're given this work plane to work with, and unlike, let's say, Photoshop or Illustrator, where you have an X and a Y, we now have a Z, right? We now have depth. And so you can kind of rotate this around. I'm just clicking my middle mouse button here to move that plane. That's kind of drawing. And I'm going to click my right mouse button, and you can see I can actually rotate around this space, okay? And because this is a 3D modeling program, just like working in vectors, it doesn't really matter at this point the scale that you're creating this in, okay? So we could create a box the size of my house. That's okay, because when I go and print it, I can kind of scale that down. And in fact, it'll automatically scale down to the software that we're using anyway, the printer that we're using. So I might just quickly bring that up. So here is my printer software for the gents. And I'll explain how this works a little bit later. So let me just jump back to TinkerCad. Okay, so when you start working, you don't have to stress too much about sizes, okay, because we can fix those a little bit later. So don't stress about that. All right, so here's our working space. If I hit home at any time, it brings us back to that home position. If I hit this one here, I can basically sit just to a front or just to a top view. I can automatically align it. Or again, hitting home will bring us back to that kind of view there, ready to go. And you can see my grid is snapping to a 1 mil grid. Okay. All right. So now let's make some stuff in 3D. All right. So it's pretty easy. So what TinkerCad does to try and make it easier for you and for students is instead of giving you nothing to work with and you have to kind of create everything from scratch, they give you a bunch of shapes, okay, a bunch of primitives to work with. And I think that's really good because it's a lot easier to work from shapes you already have. Okay. So creating something out of something else is a lot easier. You can use the shapes and you can use these elements to create something. It'll save a lot of time. So we have some basic shapes, which are all down the side here. If we click through here, we have text and numbers, obviously. And then we have some characters, all right, and those are just kind of like elements. So like you can build a little person with this kind of stuff here as well. Connectors. Now connectors are great. So connectors are if they're going to create something, they want to have movement to it. They want to have multiple pieces. That's what these connectors are for. So they're automatically designed to work with each other. So this socket here, for instance, will work with this rotating ball joint. So this will click into that space there because when you print with the 3D printing filament, there is some give to it, right? It's like plastic. So you can kind of push that in there and then you have a rotating socket, okay? So you can use these elements to create some, like a robot, and they're already done for you, and you can scale those up and down to fit as well. So connectors are really good to play with. Then we have, if we keep scrolling down here, we have furniture, okay? So maybe they're designing some kind of house. They can do all that through there as well. As we go through, they're doing some stuff for making it home. What this is it's actually pretty interesting. So making it home means these are elements that you would find at home, and they're to scale, and it allows you to create something in 3D using these elements. So I can use tissue roll holders, paper roll holders, build some kind of 3D model here, and then because I don't have access to a 3D printer at home, I then use these elements that I found right at home to build it. So you can use TinkerCad to kind of build your robot. Yes, honey? Okay, what would you like to do? Okay, so do you want to just maybe go outside and play for a little bit? Okay. Sorry about that. So yeah, so what we're going to do is they can actually build, they can build their 3D model here, design it all up, share it with their friends, and then their friends can actually make it with these elements at home. You can watch me if you want, bud. Do you want to look about how to make stuff out of 3D? Yeah? Do you want to get your step ladder? Cool. All right. So Rash just. All right. I won't start. So Rash just getting his step ladder so he can join in with me as well. So yeah, that's what this making at home section is. So that's probably pretty handy right now. It's geared towards Americans, so we have quarts of milk and stuff like that. But that's what that is. As we keep going down here, we have a few more things. We have shape generators, all right, which will load up here, and that is these elements. All right, come in. All right, you can step up. All right. So Rash is going to join us. Okay, bud, can you see? What I might do for the sake of my dear Raph is I'm going to show you what we're looking at, buddy. So, look, there we are here.
Like TinkerCad.
It is like TinkerCad. Okay, so I'm up here, Raph. There we go, so that camera there. So, we can't really see you. Where are you, bud? There you are. You can say hello. Alright, so let's get back into it.
Okay. Dad, you can't do that. I need to see.
You want to see my screen?
It's going around.
There we go.
Yeah.
Okay, so Raph can see as well. Alright, wonderful. Alright, I might just turn me off so you don't need to see me. Okay, so then with these images here, these are generators. So these allow you to create elements and then change the properties of them. So generate, like make something. This is cool. Now I've got someone who can ask me questions on the fly. I like this. So if I kind of drop in a spring, you've then got your spring down here, okay? And then we've got a few options with that spring. We can change how many rotations it has. We can change the offsets. We can do those kind of things as well. Well, that probably was a little bit big. Yes, darling?
And what are you making?
I don't know yet. We'll figure it out. We're going to make some kind of 3D model. Maybe we'll just make a box or something.
What is it? Just make me.
Make you? I'll try. All right. So that's what your generators are. Okay. And there's quite a lot of those. If you scroll down, there's like normally 2 pages. So you've got sprockets and joints and those kind of things as well.
Build something.
Yeah, I'm going to very soon, buddy. Then we have...
Pause.
Yeah? Okay, going to the toilet. Rash is going to go to the bathroom, and I'll talk about some other things. We're not building anything yet, though. And then we have some different collections down here. So you can actually start to... It's okay. You can actually start to create a collection of elements that... Okay, buddy. A collection of elements that you're going to use a little bit later. You can do that down here as well. Okay, so now we've done that. Raph will be back in a second. I'm sure he'll be the highlight of this session today. It's wonderful. I'll show you how we're going to actually build anything. Now let me just make sure we've got everyone there. Okay, chat's working okay, which is good. All right, so what we're going to do now is we are going to kind of create some kind of 3D element. Okay, so we're going to get that model built, and once it's ready to go, we're then going to use that and we're going to start to print it. Now, I don't have a printer at home, so I'll do that in software. All right, Raph's back. Good work. Okay, so let's build something, Raph. So what we're going to do is we're going to use a shape. Now, we'll build something really simple. We'll build like a house as a real simple example. Okay?
And then can you like actually 3D print your house?
Yeah, we can. Yeah, we can go to the tech school and we can print it. Maybe you and I'll go for a drive and get it printed. We'll see Graham and that. Okay, so what I'm going to do... No silliness today, okay? All right, so what we're going to do is we're going to drop our cube in there. So when you click on any of these elements, it automatically drops into this space. And so what we're going to do now is we're going to kind of have a look at what this looks like. So I can kind of scroll in here. All right, so there's probably a little bit of lag at the moment, mainly because I'm doing about 5 different things on my computer. I'm recording this screen while streaming, while doing everything else as well. So probably a little bit of lag here, but you should be okay on your end. So we can see we've got the default size there. Now I can scale that however I like. I can change those dimensions, okay? I can click on the number and type in the dimension and do it kind of manually that way. So if we want to be really precise, we can do it like that. Okay, and you can see I've got these control handles here, so that's for changing the scale as well. I'm going to undo that, and we've got our rotation. Okay, so we can kind of move that around as well. And that's pretty much how you can move these elements. It's pretty basic movement, but it's enough to kind of get what you want. Now I'm going to rotate around here so you can see what's going on.
Yeah, build a house.
Yeah, we're going to build a house, bud. So I'm just going to bring that back to our front view there. All right, so now we've got our square. Okay, so it's as simple as that. Now, if we want to then, say, put a hole in this box, all right, let's just say we want to give it a, we'll make a tunnel, right? Why don't we make a tunnel?
Dad?
Yeah, buddy.
Is that the middle? Is that like the floor of the house?
It's just a box. We're just doing an example. Okay. So we sure can. Yeah, we can. So then what we're going to do is I'm going to give this a tunnel. So how TinkerCad works is again it uses shapes to edit or create shapes. All right. So the first thing I'm going to do is I'm going to grab a cylinder. I'm going to drop a cylinder in there. Okay. And then I'm just going to kind of rotate this cylinder around. So, well, it's a cylinder, bud. So it's kind of like a circle, isn't it? So I'm just going to zoom out a bit. And I'm just... It's a very tall circle, yeah. And I'm just going to rotate that around. Oops. So let's just kind of zoom in a bit. It's a bit tricky because, like I said, there's a bit of lag going on with my screen and you. There we go. So thanks, buddy. So now I have my cylinder here. What I'm going to do is I'm going to bring that scale down a little bit. And I'll bring that across here.
Looks like a chair.
Yeah, it does look like a chair. All right. And what I'm going to do now is I'm going to kind of bring this out. All right. So now I have kind of this cylinder shape here. I can move it by holding it, and I'm going to put it through that box. Okay. So now if I kind of scroll around, sorry, you can see it's through that box there. Okay. And what I might do is look, I'll put it a little bit higher. There we go. So now we've got my cylinder through that box. So we have two shapes here. So if I was to send this to the 3D printer, it would just print this as one shape. Okay. So what we're going to do is I'm going to click this one up here. And I'm going to change it to what's called a hole. Okay. So what it's done is every shape has a solid and it has a hole. Okay. And so once you change that element, so now it's got a hole in there. Okay. Now that element is essentially see-through. Okay. So now what we'll do is if I hold shift and select both elements, okay, the one that I made see-through and the one that's still solid, and I hit this merge, there we go. So what it's done is it's combined the two shapes together, and because one shape I said I wanted to be see-through, it's then kind of punched that through that square. So now we have kind of that square with the tunnel through it.
Like a train tunnel.
Like a train tunnel, exactly right, right? You can undo that because the shapes are still there. As you can see, if I double click it, it still has that shape there. It doesn't like merge it and then destroy the information. It's still there as well. So that's ready to go. So there we go. So that's kind of how we make some basic shapes. And then we start using our other shapes that we've got, and we can start to build stuff. So
triangles on the top of the house.
Exactly. So let's do that. So we'll get this, and we'll put it on top of the house. Now you got to remember you're working in 3D space. So if something looks right on one angle, it might be completely off on another angle. So you've got to constantly be working, rotating, and making sure that you're kind of in the right area. So they'll snap a little bit too. There we go. So now we have our house. What's wrong with my house, Ram?
That's not a very good house.
Not a very good house? What should I do to it? Chimney.
Yes, but it's a bit small.
Well, we can make it super big by zooming in. All right. So there's a...
It's going to be like... So what's that big shape?
On the bottom?
Yeah.
That's like the floor.
It's going to be like as big as that.
Yeah.
I want a huge house.
Well, we can print it. Okay. So there's our kind of our rough house. And then as we start adding other elements in here, okay, you start to kind of combine those together into different shapes. So now I've got that there. I'm going to select these two elements here and merge them together. All right, and you can see how it's combined it into one shape. Okay, so that's really helpful. Oh, gosh, this is tricky to do all three things at once. That I'm gonna just change that. Okay. Thanks, bud. So that's our house there, ready to go. Okay, so we can kind of move around. It looks like a birdhouse. In fact, why don't we make a birdhouse? All right, while we're at it, let's 3D print a birdhouse. So to do that, let me grab, I think, another cylinder. I'll put that there. I'll just kind of rotate over here.
It can be the bird seed.
Yeah, exactly. And I'm going to scale this down. All right, and I'll make that a bit longer. There we go, and I'm going to move that into here. And again, we'll just kind of rotate down.
The stick.
Yeah, we'll put that in there. Holding shift to scale it uniformly. Ooh, there we go. Let's just zoom in a bit. When I'm done, buddy, we can make something together, okay? There we go. All right, so now as I kind of rotate around again, you can see what looked accurate in one dimension is not accurate in the other. Oops. So I'm just going to select that and move it. There we go. So now we kind of have that section of our birdhouse. Now remember, we're going to get these two elements and combine them. So it creates one element, which helps us when we start to actually print this in 3D. All right, I'm just going to double check my feed again. Sorry for keep checking, but I just want to make sure that we're coming through okay. All right, it looks like we're going all right. Okay, so let's just make sure, because the chat is very quiet, so I want to make sure. Though not many people seem to use chat. I don't know why. There we go. Yep, I'm coming through live on there. Excellent. Okay, I'm going to close that down again. Hold on, bud. We'll get a bigger chair for tomorrow. Okay. All right, so there we go there. I'll head back to it, my birdhouse. All right, so then let's do one last element of my birdhouse. Let's do, Raph will do the big stick that's hanging on, yeah? That goes into the ground?
That's a big stick.
Well, then we need one that goes into the ground. Should we do that?
No, it doesn't go in the ground. It's on a huge tree, so to make the cylinder really big.
Okay, so,
it needs to be on the...
well, what if we put a hole in the top so we can hang it?
No.
Tie some rope for it? I might just do that. All right. So what we'll do is we'll do one last element here for our birdhouse. We'll kind of rotate that down.
Make it really small.
Yeah, I'm going to hold shift to make it small. I'm going to move that across. I'm going to pick this up. I'm going to put it as a...
Big.
Yeah, we're not going to use all of that. I'm going to pull that up to there. I'm just going to hold shift, make it a little bit smaller. Alright, and I'll just move that through. Yeah, okay. That'll do for now. And then we make that a see-through shape. Okay, so we know it's going to kind of cut a hole through. Again, I can see I might actually have it a little bit higher. And then I'm going to select my two shapes there. Select my two shapes. And I'm going to merge those. There we go. So now we have that opening that we put in there. Excellent. All right, so that is our 3D model. Okay, so very, very basic. Now, of course, the more time you spend here, the better your model can be. Now, again, you don't just have to use these models that are here as well. You can import a model. If I hit import up here, you can import any kind of 3D model that's already made.
What's important?
Import means bring in, like I'll put it on. So if you go to places like Thingiverse, okay, in fact, I might even bring that up for us if you haven't used it before. Thingiverse is basically it's a depository of 3D images and 3D elements that you can make, and it's all free, which is good. So I'll bring that up here so you can have a look at it. So through here, you can search for almost anything that someone has made. Yeah, there is a bear. What do you want to look for, Raph? Well, think of one thing we could look for. A Pokemon. Pikachu.
Pikachu.
All right, let's look for a Pokemon.
Well, look for
Squirtle. Okay. So what we have down here, look, there's Pikachu. What we have down here is a whole bunch of 3D models of Pokemon. Okay, so people basically build stuff in 3D using TinkerCad or using some more complex 3D programs.
Why did I put it like that?
Those ones?
Yeah.
Oh, that's cool. I'm trying to find a nice simple. Let's just find Yeah.
Squirtle.
Yes, that guy?
Yeah.
Is that Squirtle?
No, not that. The one without the glasses.
Ah, Raph knows his Pokemon. I don't know. Hey, look, how about a Pokeball? You want to print a Pokeball?
Can I open?
Might. So yeah, let's find a 3D object and we'll download that and I'll show you how you import one of those. I'm going to do this low poly Gengar. Okay, so I'm just going to download that. I'll do that off screen because you don't want to worry about doing that.
Stop.
Oh yeah, that's me there. Raph, I'm working on that as well. All right, so I'm just downloading that Gengar, and I'm just going to open that up.
Oh, that's right.
Alrighty, so let me just put that across here. Files, let's go STL. Okay, let me head back to TinkerCad. Hold on. Alright, let's go back to TinkerCad. I think I've lost TinkerCad. Alright, here it is. And we'll head back. Okay, so I'm just going to bring that down here.
Your birdhouse.
Thanks, buddy. So, yeah, you can import other 3D objects as well. So I'm going to go into here. I'm going to go to my desktop. Let's see if I can find where it went. Let me check that. It's a Gengar fix STL. I might just drag that in. Cannot read. Let's drag it from here. Alright, we got there in the end. Okay, so I'm just going to import that.
Are you going to make just a Pikachu?
I think it's called a Gengar. Alright, so I'm just importing that model. I'll see how we go while that's doing that. So yeah, so you don't. There he is. Whoa, there he is, Raph. Now he's massive. So let's move him out of the way. And I might even just scale him down. So yeah, so you can import 3D printed models or 3D models that are already made, and you can work from those as well. Okay, so that's where things like Thingiverse are really, really helpful. So I'll close that. Yeah. So if there's something you're looking for, you might want to go in here, try and find a version that someone's already made, and make some changes. Because everything in Thingiverse is Creative Commons. Okay, so everything that's been made here has been made so other people.
Yeah, I like those Pokemon.
Cool. All right, well, we'll do those a little bit later, right? All right, so let's head across. I'm just looking at the time. All right, we've got a bit of time. So yeah, so you can import models as well, and you can work off those. So I'm going to delete Gengar because I don't really want him in my shop. All right, so now we have that. We can keep on going. We can keep on building and making stuff here, or we can print it. I might just show you a couple of other things you can do as well. So if we click this little Minecraft-looking icon up there, let's see how we go with it through here. It's just loading a little bit. All right. I might just be struggling to load. I guess lots of people are probably using this at the moment. I might just head back to my model. I might even try the Lego one. See if that's going to work for us today. There we go. And I'll make it more detailed. There we go. So what? Yeah. Made out of Lego.
And what's that little base bit?
That's just the logo of TinkerCad. So what that does is that basically shows you what your 3D model would look like out of Lego bricks. And it shows you the exact bricks that you need to use as well to build it. So again, you could use this for your students that are at home. You know, they don't have access to a 3D printer. Maybe they've got access to a lot of Lego. I'm looking at you, Graham. So maybe they could build something in 3D. Use the Lego section. Use the Lego section, and then then build it. Okay, and they can actually get the plans out of here as well. They can see exactly how it works by going to layers. They can see how it works. So we can go up by each layer. Look at that, right? So you can go up by each layer of Lego to see exactly how to build it. Okay, so that's an option there. The Minecraft one up there didn't seem to be wanting to work for me today. That basically will build your 3D model in Minecraft style, by bricks, which is kind of cool as well. So that's what that one is there. All right, so once you've got your 3D model, all right, yes, buddy?
Like me.
Make Raffy in 3D. I don't know if I can handle you in 3D, buddy.
No, like all of me.
Or Lego.
Yes.
We could do that. All right, so once you've got your 3D model,
Like my pussy.
we might look at now how we actually print that. Okay, so a couple of things before I do. I might just go back and show you how this works in terms of sharing. So we've got a couple of options up here. Okay, so import we just talked about, how we import models. Export, this is how we actually get that file out. Okay, so you can see we have a few options. We can download it in a certain amount of file format. So OBJ and STL, they're probably the main file formats that you're going to be looking at. STL is probably the most common, but all of our laser cutting software, yes, darling?
Where's the first person?
Just here. All the laser cutting software that we use at the tech school, a little bit quiet, please, uses both of these formats. For laser cutting, that's using an SVG. So that's for generating something which you can bring into Adobe Illustrator or into a laser cutter piece of software. Okay, so that's kind of like a flat packed version of this. So it won't necessarily work with a 3D design like this, but if you're maybe building, you're making building designs for like some furniture or something like that, you want to flat pack it, you can do that in here and then download that SVG file for printing with a laser cutter or a CNC machine. So again, machines we have at the tech school. So that's how you do that. Now, before I do that and go into printing it, let me just show you a couple other options you can do here. Obviously, you can rename your file. It just gives you a randomly generated name to begin with. I'll just call it Birdhouse. Okay, done. And I'm just going to go back here. All right. And so what you can do down here is you can do a couple of other options here. So in terms of your design, you might want to share it. So by default, they're all private, okay? But if you want to, you can put it into a public view, and then you can share this, okay? So what it'll do is it'll generate, I'll save those now, it'll generate a link, okay? So, similar to a YouTube link, and then you can share that link, and then other people can get your model, and they can make changes to it, they can edit it, they can build upon it. So again, something really good for your students to do. You might get one student who might want to create something, or a group of students want to create something. They can share their models around, and people can build off that. Okay, they can modify the design, make changes, and build off that. Or you, as a teacher, might build a model, and you want them to kind of build from there as well. So you give them a base model. You might actually download something from Thingiverse and say, hey, this is your base model. I want you to build a house for it. I want you to build scenery for it, or something like that. So giving them something to start with is really handy, and you can do that by changing it from public. From private to public down here as well. I'll just switch back to private because people won't know what we're doing here. All right, so that's kind of it there. So I'll go all the way back to my designs just to show you this as well. Now everything, so you can see it's saving. Everything is cloud-based. So once you log in, you can log in anywhere. Okay, and whenever you log in, you'll have access to your designs. All right, and it saves pretty much automatically too. So it's all cloud-based. So hopefully, the internet is working for you okay, and you can do that as well. So you can see they're all private, but if it was public, you can see how many people are talking about this and sharing it and those kind of fun things. But anyway, we'll get back into this one. We'll go back into Tinker, and I'm just going to show you how we download these, and then I'm just going to show you how we would print them at the tech school and the considerations you have to take into account when you're printing something. All right, so let's do this. So I'm going to export it. I'm going to export it as an STL, and there it is there. It's downloaded it. Okay, so that's sitting there in my download folder. All right, let's get up some software. So.
Nothing fun.
Sorry, John?
Is this anything fun?
Yeah, we're now going to print it. We can't print it here, though. Print at the tech school.
So, when can we go there?
I don't know. Maybe we'll go later in the week if we're allowed. See Graham and Matt? Anyway, so what I'm going to do is I'll just delete this thing I was tinkering with before. So what we have here is this is the software that we're using for our 3D printer. Yes, darling?
And when you go there, can you 3D print those little Pokemon with the holes in them?
Sure. We can email Matt. We'll ask Matt to do it.
And
yeah,
the 3D squirrel.
Okay, we'll do that. We'll ask Matt to do that. Okay, so now we have this. So this is our 3D printing software. Now, this is designed for our printers. Okay, that's why they're there. So I've got it set up for the double jets. Okay, so the double means it actually has two heads that will extrude material. Okay, so normally you have one head, so one bit of filament, maybe just red. But with a double, you can print two colors at once, and it can change those as you go through. Okay, the industry I haven't even touched yet. I'm sure Matt will tell me all about that one. So this is set up for that double. So it's the right dimensions, the right size, and everything needs to fit in there. So now we're going to print that birdhouse that we made. So I'm going to open up the file and add the model. Okay.
Why is it loading it? Like I did the Lego.
So we're done? Oh, it's just it's kind of like buffering, I think, on that end there. So what I'm going to do, let's see if I can just drag it in. Oops, that was the Gengar. Where was the one that I made, Raph?
Ready?
So, darling, let's just find my model. Alright, I think it's Mum's home. Okay, so there's my, let's go to my desktop, sorry.
Shall I get back to lighting?
In a sec, darling. Alright, I'm just going to bring that in. Alright, let's just head back to TinkerCad to see where it's saved that save. Okay, so export. I thought I saved it to the desktop. STL. Oh, it's in my downloads folder. Okay, so that's where it's going to put it by default. It looks like it just automatically puts it in your downloads folder. It doesn't really give you an option to put it somewhere else. So let me just head into my Gen software again, and I'm going to drag that in. See you, buddy. All right, I'm just going to shut the door, mate. All right, so you can see I've dragged it in here into my 3D printing software for the gens. Now you can see the scale it came at. So that's the scale that we built it at. But if we have a look at it, it's pretty teeny tiny, right? So it's not a huge model. If we have a look at the scale there, what is it? About 20, so it's about 2 by 3 centimeters. Okay, so now we've got it in there. We can scale it up if we want to. Okay, so I might just scale that up to, I don't know, let's make it 500%. There we go there. Okay, so now it's a lot bigger. You can see it's still in the right place. If I kind of move that out, I'm going to go into move here. If I move that out, you can see it's red now because it's out of the dimensions we're allowed to use. Writing time? Alright, you take... Sorry, Ruff's just going to finish his writing, so please be careful. I'm just going to help him so he doesn't destroy the office. Alright, you take your book. Yeah, you're talking about the beginning and the middle and the end. Yeah. Well, just in case nobody doesn't know. You take those, and you're doing beginning, middle, and you're just about to do the end of the story. Right, here you go.
And give me my pencil case too.
Okay, it's just over there. Alright, so now we have our model. You can see it's red because it's out of the printable zone. So I'm just going to kind of move that back in here. That should turn great. Okay, so now it's telling us that we can actually kind of print this. It's fine. So you can see the size of it. It's pretty big. That is now, what is it? We're looking at, we'll go into our scale. So we're looking at about 10 by 15 centimeters. So you can see kind of the limit of that 3D printer, right? So the biggest that's going to be is possibly 20 centimeters, Matt. I'm sure you'll be able to tell me. But you can see the scale that you can print this at. So now we've got that, we're going to get ready to print. Okay, so this is where I want to show you a few of the other options that 3D printers do. So if we were just to print that as a solid piece, okay, we'd be looking at hours and hours and hours of printing and using a stack of material because it's going to fill that whole thing in, which we don't want to do. Okay, it's going to take too long. It's going to be very expensive to do that. So I'm just going to go into my settings up here, and you can see you have a few options. Okay, you have a thing called infill and an infill pattern. So infill is what is inside of this. Okay, what is the material it's using inside here? So I'm going to change it from an infill percent. I'm going to make it like, I'm going to bring it down. Well, it's going to yell at me because it's saying that's not a good idea. But I might, look, let's just bring it at default 20%, and we'll leave it as a grid. Okay, but you've got a lot of options on how this is going to look. How is it, what kind of pattern is going to be using for infill, and I'll show you this in a second. So that's what that is. Then, oops, I'll go back to my settings. Then you've got your side walls. So how thick are the walls here? So again, that's kind of just how thick you want those walls to be. So you can have the infill, fairly low, as long as the walls were fairly thick and strong. And again, it depends on the uses. Like, what is this going to be used for? Do you have to have a really, strong walls? Does the bottom need to be really strong? How's this 3D print being used? And that's what those are there. Your bed adhesion, okay? What that is I'll put it on raft. That is like, it almost prints a bed of 3D printed material before it prints the actual element itself. Okay, so it does that, so it's got something to easily kind of come off as well. All right, And that's pretty much all we need as well. The last one here is called supports. Okay, now let me see. I won't need supports on my model, but I'll show you what they are. So with supports, you've got auto, manual, and disabled. Okay, so if I go into manual here, you can choose what kind of support you need. Now, a support, if I could explain the support, I guess a little bit better, let's just have a look at this element here. Now, because that element's flat on the ground, all right, that's going to be pretty easy to print. It's going to build it up. But if this was sticking out here, okay, and coming out the top here, all right, what will happen is the 3D printer is printing this in layers. So it's going to try and print that, we'll call it that pole, right? It's going to try and print it coming out here. Now, obviously, it can't do that, right? Like, it can't print in air. It's going to fall. So what a support is think of it like a beam, all right? And it will print this beam first that it will then support that pole on, okay? So it can actually print that. Now, what I would do, though, if this was sitting up here, all right, I probably actually wouldn't print it like this. That would be a bad way to print it, okay? Because it means that it has to build a raft or a support to hold it up. That's more time. So what I would actually do, let's just say this did have that beam up there, is you'd probably want to rotate it, okay? So if I kind of rotate it by... I don't want to do it by that. We'll get there eventually. It's minus 90. There we go. Okay, so if I rotate it like that, okay, so remember 3D printers print from bottom to top. Now I don't have to worry about a support for this beam here, okay, because it's already going to have that because it's printing from bottom to top. So there are things you need to think about when you're designing your 3D model, all right? And that's what we talk about with the students. Like, you have to think about how this is going to print, all right, and how the print is going to work in the model that you're building to make it successful, all right? So if we went back to that, and I had that element there, and I'll just see if I can kind of play around with this, and I had that kind of moved all the way up the top, all right, then I would want to rotate this. Like, you can do it in your building of the model, or you can do it in the 3D printing software like I did, but you're going to have to remember that. How is this model going to print, and how's it best going to work? So I think that is a better way to print this if that was sitting, in the center there, or probably even how I've got it here. Anyway, I might leave it like that for now. Okay, so once we're happy with our print settings, we prepare it to print. Now I'm going to hit print. It'll start to process this. My fans might speed up again. It's slicing it. Excellent. And now it's done. Okay, so slicing, and there's the bed there. So slicing is it's going to print this in layers. So there's 621 layers. So 3D printers print in a layer at a time as it moves up. So if I zoom in here, and you can see just how solid this is, and I bring this all the way down. There we go. Okay, so there's the raft. Notice how we said we picked the raft. So it prints that first. That's not part of our 3D model. It's just the thing it's going to print on. Let me just check and make sure everything's going okay. Cool, we're all streaming fine. It looks like again there's issues on your end, but I'm okay. So what happens now is it prints it layer by layer. So you can see there's our actual model there. All right, and if I zoom in a little bit, you can see the infill. Okay, so what it's doing as we move up, there's the layers, okay, and each layer is basically that square shape, all right? So they're all hollow in there, and these are solid, okay? So that's that infill. So you can see I'm not using a solid material here. It's actually a little bit hollow, all right? And that's still super strong, right? And we can kind of see that printing up as we go. It also tells us how long this is going to take. So we can see, to print my model here, it is pretty massive, right? Like, that is a pretty big model. There's not a lot of detail to it, but it's big, okay, and there's a lot in there. It's going to take 38 hours. That's insane. So 3D printing is not fast, okay? You can get pretty detailed, and the more detailed it is, of course, the longer it's going to take. This is a pretty basic model, but it's definitely not a fast process, especially for something like this. And of course, that's what you can discuss with your students as well when we talk about manufacturing. 3D printing being, additive manufacturing, because we're adding a material into it, okay? And say something like laser cutting, my favorite, which is subtractive manufacturing, because we're taking things away from the material. This, if you were going to discuss it with your students, you could ask them, is this something that we would use 3D printing for? Is this something we would use additive manufacturing for? And I hope they would say the answer is no, because it's going to take 38 hours, it's going to use a lot of material, a lot of power to do. I could make this in a laser cutter, and that could be some simple plywood there. All right, we could have 6 or 7 sheets of ply that are slotted together and a bit of dowel, and I could make that probably in about 20 minutes. So you're going to look at what you're building, okay, and what is the better, manufacturing process. But anyway, that's how that works. Okay, so we have your layers, and we can kind of separate those. You can go back in. Maybe you're not happy with how that works. You're not happy with the time. We can go in. I'm going to undo that. All right, I'm going to go into my settings, and I'll show you what this means if I kind of bring this all the way down to like 2%. we'll take it from a grid to a zigzag. We'll bring that. So I'm going to make it like really bad, right? Like the quickest print you can do. Let's prepare that for print. And let's see what this is going to look like. It should still technically look all right. All right, so we've gone down to 11 hours, right? Just by changing those settings, we've saved ourselves a lot of time. And if I look at the inside of this, all right, you can see the difference there. Okay, a lot less infill. This area here, notice that's that internal part that we're building with the hole in it. You can see how it actually builds a bit of a support around there. That's what that red stuff is, okay? So that's a support, because again, it needs, if it wants to print over that hole, it still needs a support, like a bridge, to keep that up and stop that from falling, okay? That's what that red stuff is. The red will break off, okay? So that's why that looks like that. You actually kind of break that material off once you're done. And so even then, 3D printing requires a fair bit of work after the fact to actually polish up your model. You never get like file print and you have this beautiful, perfect 3D model ready to go. You always have to go back, get rid of the rafts and clean it up and those kind of things as well. All right, so that's probably about it, really. So that's kind of ready to go. I can hit file print, and I can then come back in 11 and a half hours, and I'll have a birdhouse. A very small birdhouse, but I'll have a birdhouse. So that's how it works. That's how 3D printing works. Okay, so we create our model. All right, we try our best to make it while we're making the model, be as creative, I suppose, in our design as possible, but also think about the limitations of 3D printing. And then we bring it into 3D printing software, and we can make some changes to how it looks, how basically try to make it print as best as we can. And then we have our model there ready to go, and we hit print, and that's it. So I don't think I have really much else to show you, because this is the point now where you really do need to play around with this stuff. You can download the Gents software. So again, these are for the printers at the tech school, Bendigo Tech School. You can download the software, no problem, and you can use it, and you can import models, and you can test it out, and you can get it ready to go. And you can, I guess, optimize it as best you can for what you want to print. And then you can basically export that as a file. So when you do come into the tech school, or again, your students come into the tech school, they can bring that file with them, and we can just plug it straight into the printer, and we can print out their object. So that's why I like the Gents as well. It lets you kind of do everything, even without having a printer in front of you. Okay, so I guess as a plan of attack as a teacher, what I would be thinking of doing would be getting your students to have a play with TinkerCad and to look at some models and build some models, okay, and have a play around with that. Talk about 3D printing and talk about how 3D printing works. We have a couple of programs that have 3D printing in them, which we'll be putting online very shortly. So I'll direct you to those once they're up, so you can kind of check them out. And they can actually see how 3D printing works, see how TinkerCad works. We've recorded a bunch of videos on TinkerCad, so that'll be there as well. Get them to make something. Get them to download the 3D Gents software. Again, it's free. And when they choose a printer, I'll just exit that for a second. When they choose their printer, what they can do is choose like one or double, and they're the ones that we are using at the tech school mostly. And then they can bring their model in and have a play with it and see how they can optimize it and see if they can get that time down to a reasonable time. And there you go. Then they'll have that file ready. And so when they pop into the tech school, once we can all come back in and be friends, they can print it out straight in the tech school. Or, Matt is actually at the tech school probably right now as well. So if you're a teacher in one of our Bendigo schools, I would dare say, why don't you have a go at building something, getting it ready in the Gents software. Paul, I'm looking at you. And then sending it, emailing it to Matt and see if he can print it for you. I reckon we could even, Matt, what do you reckon, set up a bit of a live camera, a live feed, so you can actually see it getting printed as well over those 38 hours it could take. So that's it. So thank you very much, everyone, for tuning in today to check this one out. I'm sure I'll have a lot more people watching it after the fact, like we normally do. For those of you that are coming and watching this video after the fact, we do have a bit of a booking form. If you could use that, that would be amazing. It's obviously free to do. It just gives us a bit more information and numbers that we have to do a little bit later for reporting. That'll be great. There's also a survey that we don't need to do, but we would really love it if you did. There's a survey as well, and I'll put the link to the survey. In fact, I will try and let me just find that survey link. I had it ready in my 40 million tabs I had up here. So we'll bring that survey link up as well. And if you could just use our survey once you're done and have a go at doing that, that would also be superb. Again, it just kind of helps us out in our reporting a little bit down the track. So I'm just going to bring my survey link up because I know I had it in the other video. All right, we'll kind of scroll all the way to the end. Okay, do I have it here? If I don't have, actually, no, I do. No, I don't. Anyway, I'll put the survey link up a little bit later. All right, so that would be it. So that's about it for me. So thank you very much. We have more sessions running this week. Why don't I plug those while I'm here in my last couple of minutes? I'm sure I've lost everyone by now anyway. They've moved on. So let me just go into our tech school page. and I'll tell you what we have coming up. In fact, I'll bring them over here. Let's do a bit of a plug. Okay, so coming up, what we have in the next few days is we have laser cutting tomorrow, my favourite. We'll talk about laser cutting and how laser cutting works, which is a good segue from 3D printing, obviously. I'm going to do another design thinking session tomorrow, the following day, which is all about design thinking. This is a really good one. I would strongly recommend this one for, when is the 28th actually? That is next Tuesday. I would strongly recommend this one here if you have a laser cutter at your school, which I know a lot of schools do, and they're still covered in dust. Lightburn is the software that pretty much most of the schools I know around us in Bendigo can use for their laser cutters. It's amazing. It's kind of like a combination of Adobe Illustrator and laser cutting software, and it controls everything. So you don't need to worry about this kind of stuff here, but I'm going to talk about it as well. So I'm going to do a big session on that as well next Tuesday, which I strongly recommend. And then we've got some Illustrator and design classes for the remainder of that week. And then I'll have up the following week's programs up pretty soon. So thank you very much. I'm going to jump across and I'm going to stop this feed. Remember that you will also have, I'll upload after this, the high-res version of this video so you can play it back and see it a little bit clearer. And my voice is running out. I haven't had a drink for an hour and need some water. I'll see some of you tomorrow. Okay, I'll see you later. I'm going to end the stream.